Hello, welcome to 1.2. All right, in 1.2, all we're trying to do is solve for x, or solve for the variable. It could be any variable, but in this case, it's x. Okay, so for number one, all I'm going to do is I'm going to move the 5 over, because when you move across the sign, you change the sign. So it was positive, now I'm making it negative. So this is going to be 4x uh, equals 21, that's going to be 16. So x equals 4. Now, I will say that when you get to Pearson in your homework, it may ask you for a solution set, and it will have brackets like so. You're just gonna put the 4 right in there. That's all you're doing. So that's a little. Um, I don't use solution sets a lot, but Pearson does. So just putting that out there. Now, when you get to number two, you have one of two choices. Because 4 goes into 12, you could actually divide both sides by 4, and then that would be x minus 1 equals 3. And that's when you move the 1, it's going to be x equals 4 again. Or you could distribute. So if you distributed, it would look something like this, where you had 4x minus 4 equals 12. You could add the 4 and get 16, divide the 4 and get 4. Just like it's very similar at that point to like number one. But there's two different ways to work it. Uh, the number out front doesn't always divide evenly into the number on the right side or the other side of the equal sign, but there's something that you can, if you notice it, you can use that to your advantage, and it helps keep your numbers small. It's something I like to do. On three, number three, you want to um, distribute the -6, so it's going to be x minus 6x. When you distribute, you're distributing that sign as well, so it's going to be minus 12 equals 18. Now, I'm going to combine like terms, and then when I'm on the same side of the equal sign, it's not so much about changing signs, it's just adding straight up, so or subtracting straight up. So that's x, 1x minus 6x. It's going to be -7x minus 12 equals 18. And add the 12 to the other side, and it's going to be -7x equals positive 30. When you divide something like this, you're going to get a decimal, not a decimal, but a fraction. So there's going to be x is -30 over 7. Okay. Let's see. But just because you get a fraction doesn't mean it's wrong. You might want to check your work. If you get a fraction or decimal, right, there's more fractions and decimals in your real number line than there are what we call integers, which is your whole numbers with the negatives, like -1, 3, uh, 5, -16. All those are integers, but all the numbers in between are fractions and decimals, and there's more of those. So those could be a real answer for you. All right. But I understand why it would give you hesitation or some pause to see something other than like 4 or -5 or something like that as your answer. Um, so you might want to check your work. If you see a fractional decimal show up, you might want to check your work, make sure everything's correct. If it is, then that's just going to be your answer. So I'm going to check my work. Let's see, I got x. Distribute that. See, that's a positive 1 x minus 6x. So that shouldn't be -7. That should be -5. That's going to change some things. 5x. And so 5 does go into 30. And so that's going to be x equals -6. So I could have been in a situation where that fraction was just going to be my decimal or my answer. The fraction is going to be my answer, right? I checked my work just to make sure, and I made a mistake. And any teacher is just as capable of making mistakes as you are. We just know how to own our mistakes, hopefully. And especially in math class, you're going to learn more through your mistakes than getting things right. All right, for number 4, you have an x and a constant term on both sides of the equal sign. So at this, because we're dealing with equal signs, it's really just a matter of preference. So do you want your x to be positive? Do you not care? All right, I'm going to move my x's to the left. So it's going to be -7x. Okay, so that's going to get rid of that. And that's going to be x minus 3 equals 9. Move that. X equals 12. Okay. On number 5, I'm going to go ahead and distribute. That's going to be 9x minus uh, 9 times 16 is 144. Next, I'm going to, because it would take me 2 steps to get the 144 by itself. if I move the x to that. So I'm just going to move the x here and say minus 9x minus 9x. This is going to be negative 144 equals, that's going to be 1x minus 9x. That's going to be negative 8x. And so x equals positive 18. Positive 18. Okay, on number 6, you got a lot going on here. All right, so let's do this. We got 4x minus 16 plus 20 equals 3x plus 9. All right, clean up the left side. So you got 4x. Negative 16 plus 20 is going to be plus 4 equals 3x plus 9. Okay. I'm going to say minus 3x. Minus 3x is going to be x plus 4 equals 9. Minus 4 minus 4. X equals 5. Okay, now you could do, a while ago I did minus 3x minus 3x. You could do a minus 4 all at the same time. That's more of an advanced skill. If you're trying to do too much at once, that's how you start to make mistakes. Doing things one at a time, it may take longer, but it's less room for error. So you could do that if you feel comfortable, and you've done plenty of these, but just be word of caution there. All right, on number 7, we have fractions. And that's where, in a situation where we're literally just adding 1/2 and 1/3, and we're trying to find out like what the new fraction is going to be. In a situation like this where there's variables and stuff involved, I can actually get rid of the fractions. And we should all know at this point that when you add or subtract fractions, you need a common denominator. Well, if you keep that idea in the back of your mind, the number that would have been your common denominator is the number that you can multiply the entire thing by. And so, for instance, on number 7, 3 and 4, we both go into 12. 12 would be my common denominator. So let me take the 12 and multiply everything. And when I mean everything, I mean everything. So 3 goes into 12 4 times. 4 times x is 4x. 4 goes into 12 3 times. 3 times x is 3x. And then 12 times 12 is 144. And don't forget the negative. All right, I'm going to subtract the 3x from both sides. And so that's going to be x equals negative 144. Just like that, I was able to get rid of the fractions and solve my equation relatively quickly. So, all right, on number 8, we can do the exact same thing. In this case, 8 would have been my common denominator. So let's take that, 8. 8 goes into 8 one time, which means I'm just going to get rid of that denominator. 4 goes into 8 twice. That's going to be 2. 2 goes into 8 4 times. That's going to be 4 times x minus 2. Now, I don't go ahead and multiply. You could, but again, you want to make sure that the more steps you take to do things, the less room there is for error. So if you try to do too much at once, that's how careless mistakes happen. So I just went ahead and wrote it like this, and now I'll clean things up and distribute. It's going to be x plus 8 equals 2 plus 4x minus 8. One more time, x plus 8 equals 4x. 2 minus 8 is negative 6. Okay, let's see. Minus x plus 6 plus 6. Okay, so it's going to be 14 equals 3x. And when you divide, you get 14 over 3 equals x. If you check your work, you find this is actually my answer. I didn't make a mistake this time. This is actually my answer. Okay, you may think that when you get to number 9, everything's a little tricky because I have x's in my denominator, but you can still get a common denominator even if you have an x in there. Okay, so x goes into 5x, so 5x can be my denominator. So I'm just going to multiply everything by 5x. And so the x's cancel. 5 times 2 is 10. 5x cancels with 5x, so that's going to be 6. And then 4 times 5x is 20x. Okay, I'm going to subtract the 6 from both sides. It's going to be 4 equals 20x. I'm going to divide 20 from both sides. And so that's going to be 1/5. X is 1/5. Okay, all right. Number 10. I gotta find the common denominator. All right, so you work it out, however you figure it out, and you're going to find out that it's going to be 156x. Okay, so 13 goes into 156. 12 times. 12 times 2 is 24. The x's are going to cancel. 4 goes into it 39 times. 39 times 1 is 39. And then you don't have an x to cancel with, so it's going to be 39x. And then 26 goes into it 12 times. I'm sorry, 6 times. Well, 13 went into it 12 times. 13 is half of 26. So 26 goes into it 6 times. 6 times 95 is 570. All right, the x's cancel. 3 goes into 156 52 times. And then, of course, you have an x. Okay. All right. I'm going to add 52 to both sides. Okay. So you got 24. All right. That's going to be 91. 91x equals 570. All right. And then I'm going to subtract 24 from both sides. Okay. So this is going to be 91x equals 546. Divide both sides by 91. And you'll find that x is 6. So 156x is definitely a big denominator, but it's not impossible. All right. You can use things. Uh, you can use things like Desmos.com to help you figure out and use the function LCM and put all your numbers in there. That'll spit out a common denominator for you. So just so you know about that. But if you do that, I would only put in the numbers, not the x. The x, you need to be smart enough to include that. All right, on number 11, I don't just have an x in the bottom. I have what they call a binomial. Okay, and I first need to figure out which parts. So I need to factor this first one by taking a greatest common factor. So it's going to be x plus 4 on the inside. And this illustrates to me that um, on the left side, under 7, I don't need anything else. I have all the parts I need. On 9 over x plus 4, it needs a 3. Okay, so that's going to be 7, 3, x plus 4. All right, I need a 3 here. Well, what do we do at the top? Where do we do the bottom? You do the top. So 3 times 9 is 27. And then you need an x plus 4 here. Okay, and so that's going to be minus 2x plus 8. Okay, now, what am I doing? We can treat this the same as everything else. I don't need to do all that. I can multiply by what would have been my common denominator. So I'm going to take 3 times x plus 4 and multiply this out. So this is going to be 7 equals the x plus 4's cancel out. 9 times 3 is 27. This is 27. The 3's cancel out, and it's going to be minus 2 times x plus 4. Okay, I'm going to clean this up. 7 equals 27 minus 2x minus 8. 7 equals negative 2x. It's going to be plus 19. I'm going to subtract 19 from both sides. Okay, that's going to be negative 12 equals negative 2x. And then x is 6. Okay. All right. All of these problems are starting to get more and more complicated, but the process is all the same. You need to figure out what your common denominator is, multiply to get rid of the fractions, so on and so forth. Okay, on number 12, again, I need to factor this thing right here. So let me do one thing real quick. Okay. Well, I know that if I factor this, this is going to be x plus 18, x minus 18. And I know that because this is a difference of 2 squares, and the square root of 324 is 18, which means if I multiply everything by x plus 18, x minus 18, and get rid of stuff. So this is going to be 3 times x minus 18 because the x plus 18 is canceled out. This is going to be minus 4 times x plus 18 because the x minus 18 is canceled out. Okay, and then this is going to be equals 5x because I've already got both parts cancel out. And so I need to expand 12. I need to expand the left side. So it's going to be 3x minus 54 minus 4x minus 4 times 18 times 18, 72. So minus 72 equals 5x. Okay, so this is going to be negative x minus 54 plus 72. It's going to be minus 126. I'm going to add x to both sides. It's going to be negative 126 equals 6x. And so x equals 21, negative 21. Okay. Now, 13 changes up a little bit. It says let y be 0. Okay, so I'm going to let y be 0. And then while I'm rewriting this, I'm going to clean things up a little bit. There's going to be x minus 7. Distribute that negative. There's going to be plus x minus 5x minus 5. Okay, this is going to be 0, 3. X and x is 2x. That's going to be 2x minus 7. Negative 5x minus 5. Okay, 0 equals 3 times 2x is 6x. 3 times 7 is 21. Okay, if I subtract 6x minus 5x is x, and then negative 21 minus 5 is minus 26. So if I add the 26 to the other side, you'll see that x is 26. This is a slightly different way to find out what x is. They let you know if you have more than one variable, you need somebody or something to give you a value for one. Otherwise, you can only move them around. You can simplify. Like I could have simplified all this down to x minus 26, but I can't find out what x is if I don't know that y is 0 or y is some number. I can't solve for x unless it's the only variable in the problem. Okay, 14. There's nothing I can do with the 2x plus 7. So I'll leave that for now. I'm going to distribute. This is 7x plus 7 minus 5x. 2x plus 7 equals, I'm going to clean this up. It's going to be 2x plus 7. Now, at this point, uh, you might be able to recognize that if one side equals the other, then it doesn't matter what I plug in. In fact, if I can go a step further and say negative 2x, negative 2x, this is going to get rid of my x's altogether, and I'm going to be left with 7 equals 7. So now there's literally nothing I can plug in because there's no x to plug into. And then 7 equals 7 means that no matter what I plug in, I get a true statement, which means my answer is all real numbers. And this is what we call an identity because everything works. Everything works. So we call this an identity. Okay. 15 and 16 are going to be similar situations where they're uh, special things and they have names associated with it. So we're going to look at two more situations and then we'll be done. Okay. So we have, uh, let's see, we have 10x plus 4, 2x plus 4. I'm going to subtract 2x from both sides. It's going to be 8x plus 4 equals 4. And subtract 4 from both sides. 8x equals 0. Okay. And so when I divide everything by 8, x is 0. Because x equals a single number, I actually got a solution out of that. This is what we call conditional. And the difference between 14 and 15 is that 14, and no, it doesn't matter what you plug in for x, it always works. 15, you can only plug in 0, and that's what makes it work. If you plug in anything else, it doesn't work. So it is conditional. It only works under certain conditions. Now, if you're using process of elimination, you might be able to guess what's going to happen with 16, but I'm not going to give away just yet. Okay, I'm going to multiply everything by x minus 5. I'm going to get rid of my fractions. All right, so this is going to be 4x equals 20 plus, oops, 6 should be on the outside. 6 times x minus 5. 4x equals 20 plus 6x minus 30. 4x equals 6x minus 10. It's going to be negative 2x. All right, so I'll move the 6x over. That's going to give you 2x, negative 2x equals negative 10. When you divide, uh, you get x equals positive 5. Now, that's a perfectly legitimate solution, but um, as far as the algebra is concerned, it's perfectly legitimate. However, if you try to plug 5 back in, you'll notice something. You have x minus 5 in the bottom. of each of those fractions on both sides of the equal sign. So when you have you plug in 5, you get 0 in the bottom, which means you're dividing by 0, and you can't divide by 0, right? When you divide by 0, it makes the whole thing undefined. So this, unfortunately, doesn't work. And so this is what we call um, no solution, which you can write it 0 with a line through it. Right? It just doesn't work. And 14 was an identity. 15 was conditional. 16 is what we call inconsistent, because either you're like on 14, we were left with 7 equals 7, which is a true statement. In an inconsistent problem, you could be left with a false statement, or you could be left with something like this, where you get a solution algebraically, but when you plug it back in, it fails. Like the whole thing breaks apart. So that's something to be on the lookout for. Right? That's 1.2. I know that was a lot. And if you have any questions, please reach out, and I'll see you in the next video.